This function is given in the general form of f of x equals ax squared plus bx plus c. When an equation or a quadratic function is given in that form, the way to find the vertex is using a little formula where the x-coordinate of the vertex is negative b over 2a. To find the corresponding y-coordinate, we would just take whatever number we get from doing that and go ahead and plug it in for x in our function. So let's go ahead and start by finding the vertex for this one. So in our function, the a is negative 1, b is 4, and the c would be 1. But we only need a and b for that vertex formula. So our vertex has an x-coordinate of negative b over 2a, so negative 4 over 2 times negative 1. So negative 4 over negative 2, that comes out to a positive 2. So then we go ahead and plug a 2 in for x to get the corresponding y-coordinate. Oh, 2 squared is 4, so I have negative 4 plus 8 plus 1. So that comes out to 5. So our vertex is the point 2, 5. Now the vertex is the most important point to identify on the graph of a parabola, so we always need to make sure that we find those coordinates exactly. So now to get some other points to plot, let's go ahead and look at finding the intercepts. And we can also figure out which way this parabola is opening based on the value of a. So just like in the standard form, if a is positive, the parabola opens up. If a is negative, it opens down. So in our case here, a is negative 1. And so that's indicating that our parabola is going to open down. So let's go ahead and find some intercepts here. The y-intercept we find for any type of function by plugging in a 0 for x. That's usually a little easier to do in this form of the quadratic function. 0 squared is 0. 4 times 0 is 0. So 0 plus 0 is 0. Plus 1 would be 1. So our y-intercept is the point 0, 1. X-intercepts we can find by replacing f of x with 0 and solving that equation. So we could try factoring, or we could always use the quadratic formula. In this case, this cannot be factored, so we need to go ahead and look at the quadratic formula. It has negative b, so negative 4, plus or minus the square root of b squared, so 4 squared, minus 4 times a, which is negative 1, times c, over 2a. So simplifying inside that square root, we have 4 squared, that's 16. 4 times negative 1 is negative 4, times 1 is negative 4, minus negative 4, so that's plus 4. That's a negative 2 on the bottom. So we've got a square root of 20. Square root of 20 does not work out exactly, but we can simplify it. 20 is 4 times 5, and the square root of 4 would be 2. So we have 2 square root 5. And then if we go ahead and divide the top and bottom there by negative 2, we end up with a positive 2 plus or minus 1 square root of 5. Now that would technically be a negative 1, but since I have a plus or minus there already, those might flip-flop to minus plus, but either way we have both of them. So for the purposes of plotting these points, let's go ahead and approximate these values. As we have those values approximated here using a calculator, and so we have those two x-intercepts. Let's go ahead and plot these points, starting with our vertex of 2, 5. And then we have a y-intercept of 0, 1. We have x-intercepts of negative 0.240 and 4.240. So we can go ahead and sketch our parabola in from there. So connecting all our points there with our rounded U shape that's facing down gives us the graph of this quadratic function.